Hi everyone, welcome back to Fundamentals of Engineering with Farhad, Mechanics of Materials. In this example, we have an interesting problem regarding a piston, a cylinder connected to a rod, and then the rod connects to a controlling rod DE. So in this problem, we have a hydraulic cylinder CF over here, which is connected to member BD. This is member BD, which connects to a controlling rod DE. And the controlling rod is handling a force of 2 kilonewtons. So if the force here is 2 kilonewton and angle of theta over here is 75 degrees, and we also know that there is a with this pin over here is 9 millimeters in diameter, this bolt over here. And the thickness of member BD, this is member BD, is 15 millimeter in thick. We want to first know what is the shearing stress at the bolt and then calculate the bearing stress at the location of C in member BC. So we want to know what is the shearing stress at the bolt C is and what shearing stress at both C is, and also the bearing stress at the location of pin C at the member BD. Let's see how we can approach our problem. First of all, if we draw our free body diagram, so definitely this is force of AB, which applies at the end at B in member BD, and also we can transfer this force to point D as well. That's 2 kilonewton, which applies at the free end E. It just shift to point D at the member. And also we do know we have like Cx and Cy at P and C. If we just project our forces based off their X and Y axis, like here, you can easily get this is like a angle of alpha, and definitely this FAB sine of alpha, and this one is FAB cosine of alpha. We can do the same for the 2 kilonewtons at the end B. We do know this angle is 75 degrees, so this is 2 times cosine of 75, and the other one, the vertical one, is 2 times sine of 75. Based off what we know so far, first of all, if we just calculate the angle of alpha, that's a arctangent of 45 over 200 based off the distances or the length provided, and it just gives us alpha is 12.68 degrees. As soon as we have alpha, we can create a moment base of point C to eliminate these two forces and just go by FAB and these 2 kilonewton forces to know what FAB is. If you do so and jot down the equation for forces correctly, you reach to this equation. There is only one unknown on this equation, and you can easily get FAB, which is equal to almost 4 kilonewtons. As soon as we have FAB base of the moment, we can simply jot down the equilibrium equation in X and Y axis. So if we just move by X axis first, we can easily see Cx over here. Cx is equal to 2 sine 2 kilonewton times sine of 75, which is here at X direction, minus this force FAB times sine of 12.68. As soon as we have that one, it just gives us Cx is equal to 0.39 kilonewtons. Do the same, but this time for y-axis to get what Cy is. So if you do so, summation of forces at y is equal to 0, it just gives us cy minus 2 times sine of 75 minus 2 times sine 75 degrees minus FAB cosine of 1268 this time. It just gives us cy is equal to 5.90, almost 97 kilonewtons. And as soon as we get the Cx and Cy, we can easily calculate the C uh, in terms of kilonewton. That's 5.9860. Then as soon as we get the force at C, we can calculate the shearing stress at both because the area is provided. Tau average is force over the area. And if you remember, a diameter of the bolt provided to be 9 millimeters. So if you do the math, it just gives you tau average or shearing stress at both C is equal to 94.1 megapascal. And also proceed to get the bearing stress at member BD at the location of C. It just gives us the tau B or bearing stress at C is equal to the force over thickness times the diameter of the bolt, which is you have to subtract it from, you have to consider the thickness times the diameter of the bolt for the bearing stress. And if you do the math, it just gives you the thickness of the BD is 50 millimeters, the diameter of the bolt is 9 millimeters, and if you do the math, it just gives you tau B or bearing stress at member BD at the location of C is 44.3 megapascal. Thank you. We'll solve more interesting problem.